and every time we refresh, it generates a new one. Hello, I'm Jack. Today, let's talk about truchet-tiles. But first, what are truchet-tiles? Let's take a look. On this Wikipedia page of truchet-tiles, we can see there are a few variations of truchet-tiles. The first variation, contrasting triangles, consists of 4 different tiles, and depending on how you arrange them, we get a variety of different patterns. And the second variation, quarter circles, it actually only consists of 2 different tiles. And this is the kind of pattern that you can create. Before I learned about truchet-tiles, I would have never imagined that a pattern like this only consists of 2 different patterns, 2 different tiles, and which is why I'm so excited to show you how to create this in P5. And then before doing that, let's take a look at the last variation that's included on this Wikipedia page, which is diagonal tiles. That essentially is to draw a line, diagonal line on the rectangle, and then repeating that tiles. And that also only has 2 different tiles. Either something looks like a backslash or something that looks like /. But today we're going to be focusing on the quarter circles. And let's get right in. So I already give my P5 sketch a good name, truchet-tiles 1 tile. And that's because we're going to start with just 1 tile. Let's focus on 1 tile. And if we look at this, really what's happening here is we have 2 arcs, one on the top left, one on the bottom right. Let's just focus on the left one for now. But how do we draw an arc? Let's quickly take a look at the whiteboard. In order to draw a arc, it's not very different from drawing a ellipse. Let's first start with ellipse. For ellipse, there are a few arguments we need. First, we need to know the x and y. And then we need to know the width and height. For arc, it's really not that different. The only addition that we need to know is the angle of the arc. Let me get to another color. Let's say we want to draw an arc that looks like this. So essentially, we are starting at an angle around here and ending at an angle like so. And actually in P5, this angle is always 0. So what is this angle that we're looking at here? If we want to draw this arc as a right angle, that means that's 90 degrees, or in radian, that is actually half pi. So pi divided by 2. So that's the angle. So we need to specify the starting angle and the ending angle. And how do we put that together? We use a function called arc, and we start with x and y, the position, just like the ellipse, and then the width and height, and then the starting angle 0, and ending angle pi divided by 2. Or let's say if we want to draw another arc, that is in fact the arc on the bottom right that we want to draw, it happens to be this arc, which start at this angle, and that angle, if we start counting from 0, go all the way here, that is 180 degrees, and that is pi. And this angle right here, that is pi times 1.5. So let's actually count everything based on half pi. So this is, so we are starting at 2 half pi, and we are ending at 3 half pi. And let's write it here. So x, y, w, h, and starting at pi and ending at pi times 1.5. Maybe put this a little bit taller. So these are going to be the two functions that we will refer to. Let's get back to the coding. So we want to draw an arc on the top left corner of our canvas. So first of all, we have a blank canvas. want to draw an arc that is located at 0, 0. And what's the width and height we want this arc to be? That is actually going to be the same size as the size. Let's take a look at same size as the square, which is the canvas in this case. And let's actually take a look at y. So when we draw an arc like so, and if you want an arc that roughly looks like this, the width and the height that we're looking at. So this is the width of the square or rectangle, and this is the width of circle. So that width is actually the same. And similarly, this height and this height is actually the same. That's why we are going to directly be using the width and height of the canvas. So let's get back to our code. The width and height. So width is going to be the width of the canvas. Height is going to be height of the canvas, the two special variables we have in P5 conveniently. And then the starting angle. Starting angle, we start from, I'm referring back to my drawing, starting from 0 and ending at half pi. So that is another special variable that's conveniently come with P5. And there we have the arc, the top left arc, right here. Yeah, and note that this arc meets exactly at the center, and our arc also at exactly the center. Yeah. And of course, if you want that to look closer, we can change the stroke weight to be stroke weight to be slightly larger, maybe around 20, so that it's clearer. And later we can adjust it as we need. And then how do we create an arc at the bottom right? So arc 0, 0. Again, we are creating an arc based on the same ellipse size. Its only difference is angle. And we start at pi. And again, let's try to use everything based on half pi so that the math looks a little bit easier. It looks like more organized. Half pi times 2, and then half pi times 3. So I did something wrong. So this time, instead of 0, 0, which is top left corner, I actually want to draw it at bottom right. So what is bottom right? That's x equals to, x equals to width, and y equal to height. That's bottom right. So we just create the very first tile. Again, just for the math to look a little more organized, I'm going to, instead of 0, I'm going to put half pi times 0. So this is half pi times 1. If we really, I'm going to do this edit and tidy code. This, I think I'm going to keep like this. But if we add a little more space, this is, you see how this is a little more organized. But it will look more organized as soon in the next step. But for now, bear with me. Let's keep it like this. So we just created this first tile. Great progress. And let's duplicate this and try to create a function. And create a function of this tile. So one tile function. And how do we turn this into a function? Why do we want a function? That is because when we start later, we want to create a pattern like so. We will be needing to use this combination of two arcs many times. And we do not want to keep writing arcs and repeating our code. Instead, we want to use functions and for loops, and that just makes things so much easier. Function also help us make our code much more organized. And what is the function? Let's write a function that's called tile. And we literally follow the same format as the setup function and draw function. Function, space, tile, parentheses, and curly braces. That's how we form a function. But the function needs to take a few inputs. In order to make things consistent, let's try to follow the same format as the other P5 functions such as arc or ellipse or rectangle. We start with x, y, and wh refers to the width and height. So these are going to be the parameters that we were using to create arcs. That is to say, when we draw the arcs, we are going to be solely create these arcs based on those four variables. And how do we do that? And we're going to copy this and paste it right in here, and then format it. So what are some of the things we want to change? First, we really want to think about where do we want x, what is x and y, and let's. I like to think of x and y as the center. To me, that just mentally, that is a little easier for me to think about it. You can also choose use x and y as a top left corner, but again, I think it's easier to use the center. And let's get back to the whiteboard. And I'm afraid I need to wipe off the some part. Actually, maybe I can reuse this. Let's reuse this and use in here. So if we want the x and y, this x and y is the center, which is exactly how we are using it right now. So what is going to be the top left corner? So when we have the coordinate of the center, how do we get the coordinate for the top left corner? We get that by, so the whole thing is width. So this part, that is going to be half of the width. So in order to get the coordinate here, and this is the half of the height, so this coordinate is going to be x divided by, x minus width divided by 2. That's the x coordinate of this point. And then y minus height divided by 2. So this is the coordinate on that corner. And similarly, on the bottom right, that is going to be x plus width divided by 2 and y plus height divided by 2. That is going to be coordinate. And that is going to be the coordinate that we're going to use. And let's get back to our code. So now, let's actually write it out with some variables instead of putting it directly in the arc, so it's more organized. And I'm going to call the top left corner as x1 and bottom right corner as x as actually I think you know what, I think it might be even easier if we simply use letters. So let's do this. So top left corner x top left TL, that is going to be 0. Top left x or x top left. Now let's keep it this way. And then y top left, that is also 0. Oh, not 0. Sorry. We were doing is x divided by width, x minus width divided by 2, and y minus height divided by 2, which is the math that I just did right there. So this is the top left corner. And then what about the bottom right? X bottom right equals to x plus width divided by 2, and y bottom right equals y plus height divided by 2. So we just had top left, bottom right. And you'll notice how it seems like everyone's working. I didn't see any error, and that is because the tile function hasn't even been called yet, meaning that function is never run, that is never triggered. But let's try to plug these in very soon. So the x, y, top left, and then bottom right, x and y. So how do we use them? We want this, since this instead of 0, 0, we want this to be the top left corner. So x top left, y top left, and instead of width and height, we want this to be the bottom right corner. So x bottom right and y bottom right. And then the width and height, instead of the entire canvas, we want this to be the w and h. Again, we are trying to write this function in a way so that later we can plug in any number, and we can draw this tile at any position, at any width and any height. And that's where it's going to be very convenient. And since now every variable has the same width, everything looks more organized right now because we are calculating everything based on half pi here. So that's really really nicely done. And let's try to put it back in the draw function. Let's try to actually call this function. So first of all, run this, nothing happens because that hasn't been called yet. I'm going to delete the two arcs because we already have the tile function. So tile, where do I want to draw it? Let's say we want to draw it at the center, 200, 200. What's the size? 400, 400. Of course, right now, not everything is the same. That's because we are drawing the two arcs in the same way. But now we're using tiles. So what's really convenient now is we can also adjust the width and height. Let's say we want to make it to be a little bit smaller, or maybe we want it to be a little bit to the left, or maybe we want it to be a little bit downwards. So now we can adjust both the coordinate of this tile and also the width and height of the tile, which is going to be super helpful for our next step. And one other thing you will notice is these arcs come with some white components, and that is the fill color, which comes by default. If you do not want the fill, what we can do is to use a function called no fill, and that will turn off the fill, so only show the stroke. So that's really good. And I'm going to put this in the center. I might as well set this to exactly the same as before. So 400, 400 width and height. And one shortcut that I used was Command D, which is, I'm using a Mac, and if you're on PC, it should be Control D. That selects the next occurrence of the same exact match. So that I can select 400 and Command D, it will select the next exact same occurrence. So we can edit this. I can edit this at the same time. So that's what happened there. But right now we create the same tile with a function. But what you're seeing is that with that in mind, we can adjust the position and the size of this of the tile. So let's create another one. So let's try to now create the other tile. We've only created the left tile. What about the right tile? So let's get back and tile. So here is a decision that we need to make. We can either create a new function for the other type of tile, or we can integrate two different tiles in the same function. I'm going to integrate both in the same function. So tile function. So this I'm going to give a name. So tile function supporting orientation, or tile function. Yeah, let's keep it that way. So the last variable is going to be the orientation, and because I like to use tile the same way as a rectangle or a circle would be, so that I don't want orientation to be required. What I'm going to do is provide a default number, default orientation 0, and that way, even if when we use the tile function, basically, let's try this. If I add orientation here, of course, the orientation is simply ignored because we never use orientation. But if we do use this orientation, there could potentially be errors. And if I provide 0, that just means by default that is going to be the number. But if I want to specify the orientation, I can then specify that. We'll see more of that in a second. So what is orientation 0? So we have two different orientations, either the left or right. And we can define it with any number, but I'm going to call the first orientation as 0 and the second orientation as 1. And then we can write a statement. So depending on which orientation we use, we can create a different, we can draw different arcs. And if we take a closer look at the second tile, we see that essentially it's very similar, but the arc is on the top right and then bottom left. But we do not yet have the coordinate for top right and bottom left. So this is actually why I'm naming it this way. Now we can simply add to this. I'm trying to write it in a way so it's easier to read, but of course I'm not really thinking about whether it's optimized or not, whether I'm using resources well enough. But let's try to write that. So top right tr equals to x plus width divided by 2, and then y top r is going to be y minus height divided by 2. And then similarly, the bottom left, x bottom left, is going to be x minus width divided by 2, and y bottom left is going to be y plus height divided by 2. This way I can conveniently use these numbers. So again, run the code, nothing happened because we create those variables, but we never used it yet. So let's try to create a new set of arc. I'm going to comment these two out separately so that they are temporarily disabled. So now instead of top left, I want this first arc to be the top right. This to be top right. But of course, if you simply move the thing at the top right, we're not going to see anything because this arc goes outside the canvas. We want that to be that is because the angle is going to be different. So again, let's get back to the whiteboard. So for this second version, this one, the angle really start as half pi because this is 0. This is 0. This is half pi, or I guess it's a lot easier if we write pi divided by 2, and that is pi. Yeah. So we start with half pi and then end with pi. Back to the to our code. We start with half pi and end with 2 half pi. You see why I'm using half pi, so now it's a lot easier to edit the code. And run this, we just create this top right corner. And similarly, x bottom left, y bottom left, and also we want to think about angle. So the angle now, angles start at 3. Why don't we get back to the whiteboard again? The angle here this time, since again this is 0, this is half pi, and this angle is pi, this is going to be this is 1.5 times pi. So it's starting at pi and ends at 1.5 pi. And that's what's happening there. And back to the code. So we're starting at pi, which is half pi times 2, and we are ending at oh, am I writing this corner? No, we are starting at, sorry, let's take another look. That was not being very accurate. So we are starting here, which is 3 half pies, and then we are ending here. So instead of 0, we can actually try what's going to happen with 0, but we should probably using 4 half pies, which is 2 pi. And so we're starting at 3 half pi. We're ending at 4 half pi. And as promised, let's try what's going to happen with 0. Oh, so 0 works perfectly fine. That's referring to the same angle. I guess that's perfectly fine then. But in order to keep this organized, I'm going to start with 3 and end with 4. And there we have it. There we just created the second tile of this, the right tile over there. But then how do we combine that? So based on, if we want to use orientation to choose between the two, we can create an if statement. And if orientation equals to 0, so I'm going to uncomment these codes. So when the orientation is 0, let's draw these 2 arcs. Otherwise, else because there's really only two orientations. Either when it's 0, we draw this arc, or if it's not 0, let's draw the other set of arcs. And that's really all we need here. So we have function that's supporting different orientation. So now we can add a new variable, 0, which is the first orientation, 1 is the second orientation. So we just made progress. So we're really, really close. We were able to draw one tile at both orientations, both the left orientation and the right orientation. So now let's try to make it actually turn into the tile, turn into the pattern, which is the most exciting part. And let's duplicate this again. So truchet-tiles. Truchet-tiles. And yeah, so maybe I'll call it randomized. Yeah. Let's keep it this way. Let's see where we go, and then we will choose the name based on that. So this step, now what we need is a grid, and that is actually covered in one of the previous video. If you want to learn more details, you can see that video. I'm going to include a link. I'm going to include a link to that video, but now I'm going to quickly write that down. So we're starting with first of all, we need to know the columns number. I'm going to use a small number 4, and rows number 4. So number of columns, number of rows. And then based on that information, we can do some calculations. We can calculate the width of the tile, so which is the entire width, divided by columns number. And then tile height is the entire height of the canvas divided by the number of rows. With this information, we can then draw a grid. So I'm going to draw a grid from here. So for let column start from 0, this index from 0, all the way until the number of columns, and between each step, I'm incrementing that by 1. And very similarly for rows as well. And then this is where we are going to draw a rectangle. So before we draw a tile, let's just try to draw a rectangle. So a rectangle, what do we need? We need x, y, w, h. So first we want the x, and the x is going to be column times tile width. And the y is going to be row times tile height. And then the width and height we already know. That is tile width and tile height. X, y, tile width, tile height. And it looks like I made some mistake. Tile height is not defined, so I'm not spelling it correctly. Tile height. There we go. I just created a grid, but let's comment out the tile so that we are focusing on the grid. So now we have a 4x4 grid, and how do I fill in the tile? And remember, when we create the tile, the x and y is the center of the tile. So that's actually closer to how ellipse work. Or for rectangle, and remember the rectangle by default, x and y referring to the top left corner. The first one 0, 0, so that's the top left corner. What if we want to use this? So first of all, how can we get this number? How can we get the center point of the rectangle? Again, let's get back to the whiteboard to take a quick look. This time, I'm afraid I'm going to wipe these out. Yeah. So, we have a grid like so, 4x4 grid. So this first one is, so this position is going to be the indexed, which is the column index, times tile width. That's the x coordinate. And then for the height, row height times height. Yeah. So for here, 0, 0, so that's 0, 0. This one is going to be 1, 0. So that's why we have width and so this becomes width. This width is referring to the tile width, so the width 0, and this is like 2 width 0, 3 width 0, and so on and so forth. So something like this is going to be 1 2, so 2 width, and then height, and then 1 height. That's kind of how it goes. But again, this is the top left corner. How do we get the center part? If you want to get center, we really just need to shift by half of the width and half of the height, similar to what we did earlier. Yeah. And when I say shift, all I'm saying is beside this, let's just add half of the width, and let's add this to half of the height. And let's do that in our code. So we have right now, instead of x and y, what we can do is plus tile width divided by 2 plus tile height divided by 2. So of course everything is shifted. That's because the rectangle, the x and y is top left, but we can change that by changing the rect mode. So now the x and y refer to a center. And here comes. So how do we create this grid? Let's actually name this truchet-tile grid. Or maybe, it's just a grid, but duplicate truchet-tile grid of tiles. So how do we change rectangle to tile? And in fact, because we write this, we prepared this, the way we write tile is actually by this format XYWH. So we can now conveniently change rectangle to tile, and everything just works. Great. And of course, because we did not specify the orientation, it's going to be always the same orientation. It's always going to be this left one, which is why this is what we're saying. But we can already see that we can now adjust the number of columns and number of rows. Right now, the stroke is a little bit too thick. Let's make it a bit thinner, maybe like 5. So now, how do I add in other? How do I add in the other orientation of the tiles? That is really to specify the orientation. So const orientation. So this really depends on what you want this orientation to be. Let's say if you want to alternate between left orientation, right orientation, and let's there's a few different ways we can do it. First, let's say we can do that based on the column. So we want the orientation to alternate between 0 1 0 1 0 1, and based on column. A simple way to do it is to do something like so. Column modulo 2. So what this modulo does is to get the remainder of this equation. So c divided by 2 and then get the remainder. What does that mean? So when c is 0, the remainder is 0. 0 divided by 2, the remainder is 0. When c is 1, the remainder becomes 1. Because, that's the remainder. And when c is 2, the remainder becomes 0 again, because 2 is divisible by 2 and the remainder is 0. So that's how, as the number increases, the remainder alternate between 0, 1, 0, 1, so that in terms of the column, it's going to alternate. But we need to also apply this orientation here. I'm going to put this right here. So now it's alternating between the two. And maybe you want it to alternate between that, like if for instance, if you want, let's actually save this version for now. Grid of tiles, grid of maybe alternating tiles, and then duplicate this. I'm going to share the links to all these sketches so that you can see the progression and refer back to that later. So similarly, we can change this to R. That change that direction, or we can do that with a combination of these two. Plus That's where we really start to form more interesting patterns. But right now, it still looks like very much uniform. It's very much repeating the same pattern. And how do we create patterns that are more randomized, like so? So this is like alternating tiles version 2. I'm going to duplicate this again. So if we want to create a version like so, it's really about randomizing the orientation. And how do we randomize? We use this function called randomize. We use this function called random. And in random function, we can actually specify the possibility. I mean, there's a few different ways you can write this. You can either round this number. So the random function by default produce a number is between 0 to 1. So what we can do is round this number. Oh, so now that's yeah. This is already working, but it's moving too fast. That's because we put everything inside of the draw. So every frame is trying to generate a new pattern, meaning every second is generating multiple patterns. So we can either move all the code in the draw to set up so that it doesn't change, or we can also use a function called no loop, which means the draw function runs only once. You see how now it generates in a similar style as we see in this Wikipedia page. And every time we refresh, it generates a new one. So we can either round this number, meaning when it's smaller than 0.5, it's going to be 0. When it's larger than 0.5, it's going to be 1. Larger than or equal to. Or we can also, I'm going to keep this as different versions. Another way to do this is to specify the exact options you want in an array. So we want either 0 or 1. So that's an alternative way that you can do this. And let's save this as tiles of grid of randomized tiles. Perfect. Of course, now every time we refresh, it generates a new true shape pattern and randomized one. Sometimes it's really useful to be able to have the same pattern. And if you want to do that, there's conveniently we have a function called random seed. Yeah. And random seed, we can specify any number like 0. So once we specify that number, no matter how many times we refresh, we are getting the same pattern. That is really outside the scope of this this video, but simply put, the 0 is a seed, and the seed essentially defines what kind of random sequence of random number you are going to generate with a random function. So once you with the same seed, the random number you are going to generate is going to be the same sequence. In this case, we are only generating we are using this random function, so it's always going to be the same sequence, but we can always change the seed to a different number, and then it's going to generate different patterns. Yeah. And this is really convenient, really powerful. That's because now, just with this once the seed number, either it's 0 or 3 or 300, 3000, with that seed, based on the seed number, you are having a different pattern. So each seed number will represent a unique pattern. And going back, we can always change the different number of columns and rows. And you see how, because we incorporated both width and height, the reason why I keep referring to the tiles as rectangle is they don't have to be square. In this case, it's rectangle. It's a little bit stretched or squeezed, but they can still work if this is the style you are going for. I can also increase the number of rows like so. I think, yeah, 2020 feels like a good number. And I also like to change the random seed back to 0. And this is pretty much it. This is how you create true shape patterns inside p5.js, and the process for creating a true shape pattern of the other types, such as the contrasting triangles or the diagonals one, should be very similar. The one we deal with is arguably the more complicated one. The first one is more complicated, also more complicated in the sense that it has 4 different patterns, but it's really very similar process. And at this point, if you want to create the other type of true shape patterns, the only thing you need to change really is the tile function. And based on tile function, maybe in some versions you have multiple versions of orientation, and depending on the number of orientations you have, you might also want to adjust things over here. But the rest of the code almost stay the same, pretty much stay the same, because it's essentially a grid that's trying to draw the tiles. So that's something really, really powerful. And true shape pattern, even though this is a very much original true shape pattern, but there are so many, if you search true shape patterns online, there are a variety of true shape patterns. And in future videos, I really hope that I can make more videos about tiles and patterns. And again, I really hope you've enjoyed the video. I can't wait to see what kind of your own unique pattern that you can come up with based on this. And personally, when I learned about this, I was really, really excited. I was really mind blown by how these patterns are created with just 2 tiles. And this is also why I'm making this video, to share this method with you. And I cannot wait to see what you can create, and really hope you enjoy the video. And thank you for watching, and see you next time.